What's up everyone? In yesterday's video, we have learned how to do basic operations in different base system, or known as the numeral system. And we have seen the example 13 times 21 in base 4, giving us the following result, 333. Instead of regularly in base 10, we'll get something like 273. So we're going to continue working on multiplication and also try to learn how to do divisions in different base system. So let's start with an example. This time we're calculating in base 8, and what we're going to do is we now have 13 times 14. Regularly in base 10, we know that 13 or we can say it as 13 times 14, which is 14, equals 182. With the notation 182. So let's see what's the difference in here. Now, if we use this expression and put it back in base 8, we might just simply think, since we have an 8 in the second digit, we're going to add 1 to the left and giving us 202. But is this really true? Let's see. So let's do the following steps and see if it's actually true. So 13 times 1 giving us 13. 3 times 4 is 12. But since we're in base 8, we have to write it as 14. So we put the 4 here. We're going to carry the 1 up here. Let me use a blue pen. Next, we have 1 times 4, which is 4, plus 1, giving us 5. And now you love the two numbers, we get 4. 3 plus 5 is 8, which is 10. Right, not 8, but 10. And we are going to carry the 1 here. And we have 1 plus this 1, we end up with 2. So we need to be very careful in our calculations, especially when we're doing multiplications. The old multiplication table no longer applies, and we cannot use the notations we know of to base our calculations. Otherwise, we'll get a different answer from what we should have. Next, we're jumping into division. In fact, division is similar to multiplication, which means we can do the same way as how we usually do in regular calculations. And of course, the only difference is we need to use a new multiplication table that we build. For instance, let's say we're calculating numbers in base 12. And in base 12, how are we going to represent the numbers 10 and 11? Most of the time, we will see people using capitalized letters A and B to represent 10 and 11. So here is our example. Let's say if we want to find out 1 divided by 23. Now keep in mind, 23 in base 12 is not the same as 23, which is in base 10. How are we going to rewrite it in base 10? Well, 23 in base 12 means we have 2 copies of 12 to the first power plus 3 times 12 to the 0th power, which is 1. Giving us 27. So in our notation here, even we see 2, 3, It is actually referring to the number 27. So how are we supposed to do it? Again, we can just do it with the long division, like how we usually do the calculations in regular base, or doing the long divisions such as for polynomials. And the way we write it is still the same. Since 1 is less than 2, 3, which is the divisor here, we can just do the same thing as how we do the long division in regular base. To do so, we're going to put what's so-called the decimal point, and some people would just call it the decimal separator. But of course, in this case, we're not doing in decimal, not base 10, we're doing in base. This is still working the same. It is the separator to divide up the integer part and the fractional part. And after that, we just put down the zeros. And we're going to start our calculation. Since we're in base 12, not in the regular base, we might as well just make our multiplication table for particularly 2, 3. So let's draw the chart on the left hand side, and we're going to do this. Let's move back to the long division. So 1 is smaller than 2, 3. So we just put the 0 down here. Move to the next digit. Now we have 1, 0, which is still less than 2, 3. So we'll just put another 0. Now we combine with the next digits. We read it as 1, 0, 0. Again, do not read it as 100 because this is not the same as 100. We're in base 12, not base 10. 1, 0, 0 divided by 2, 3. Well, let's see. From the chart, the biggest number we can get that is not greater than 1, 0, 0 on the right hand side is B3, which means the largest number we could put up here would be 5. And again, 2, 3 times 5 giving us B3. And if we do our subtraction, 0 minus 3 is not enough, so we'll borrow 1. 1, 0 minus 3 in base 12 means 12 minus 3 giving us 9. Since we borrowed 1, now we instead of 1, 0, we just have B. B minus B is 0, so this is the remainder so far. And now we're going to carry the 0 down to finish our calculations. Luckily, if we look at our charts, we do have 9, 0 on the right hand side. And we check that 2, 3 times 4 equals 9, 0. So what should we put up here? Right, we'll just put a 4. And then we will multiply 2, 3 by 4, giving us 9, 0. And if we subtract it, we get 0. So this is how we're doing division in different base system. Okay, at the end of this video, I have 2 problems to let you guys think about. Number 1, are all terminating decimals in base 10s always terminate in any other base? And problem number 2, can a repeated decimal in base 10 be terminated in some other bases? So that's it for today's video. If you have any thoughts, please leave your comment down below. And if you enjoyed this video, don't forget to like and subscribe. I'll see you in the next video.